In the early 2000s, NVIDIA was just a company that helped teenagers play video games with better frame rates. But while we were playing games, they were building a god. Today, it is January 2026. NVIDIA has officially surpassed a $5 trillion market cap, making it the most valuable entity in human history. They aren't just a chip maker anymore. With the launch of the Rubin platform this month, they have achieved something no company has ever done. They have successfully vendor-locked the future of intelligence itself. Right now, sovereign nations are treating the R100 chip like enriched uranium. If you have them, you're a superpower. If you don't, you're obsolete. This is the story of how Jensen Huang built the world's most dangerous monopoly, and why the great rotation of 2026 might be the only thing that can stop it. And NVIDIA genius wasn't predicting ChatGPT. It was CUDA. In 2006, they released a software layer that allowed their gaming chips to do math, not just pictures. The world of high-performance computing was, at the time, a labyrinth of specialized esoteric programming languages. If you wanted to run a complex scientific simulation, you needed a team of PhDs who could write code for a specific arcane piece of hardware. NVIDIA's vision was deceptively simple. What if the powerful processors inside every gaming PC, the GPUs, could be used for general-purpose parallel computing? This was the birth of CUDA, or the Compute Unified Device Architecture. It was a revolutionary platform that opened up the massive parallel processing power of their GPUs to a broader audience of developers and scientists, not just graphics engineers. For a decade, this move was largely dismissed by Wall Street. Investors saw it as a costly distraction from their core business of selling GeForce cards to gamers. They called it a waste of money, a solution in search of a problem. Analysts questioned why a hardware company was pouring hundreds of millions of dollars into developing a software ecosystem that yielded no immediate obvious return. During this period, competitors like AMD and Intel focused on the CPU market, the traditional brain of the computer, seeing NVIDIA's GPU computing efforts as a niche, academic pursuit. While they focused on making single-threaded tasks incrementally faster, NVIDIA was quietly building the foundational tools for a new paradigm of computing, one that excelled at performing millions of simple calculations simultaneously. This decade of seemingly thankless investment created an impenetrable moat. When the deep learning revolution ignited in the early 2010s, researchers like Alex Krizhevsky discovered that NVIDIA GPUs, powered by CUDA, were uniquely suited to training neural networks. The architecture designed for rendering complex 3D worlds in video games was, by a stroke of strategic genius, perfect for the matrix multiplications and parallel computations that underpin all modern artificial intelligence. Suddenly, NVIDIA wasn't just a hardware provider. They were the essential toolkit. An entire generation of AI researchers, data scientists, and machine learning engineers grew up speaking CUDA. It became the default language for building the future. Moving to a competitor like AMD or Intel isn't just a hardware switch. It's like trying to rewrite the entire English language overnight. Every foundational paper, every open-source model, and every university curriculum was built on their platform. They didn't just sell the shovels for the gold rush. They had invented the concept of digging. In 2026, we've entered the era of sovereign AI. This is no longer just a corporate arms race. It's a geopolitical imperative. Countries are now behaving like the world's largest venture capital firms, but with national security at stake. Nations like Saudi Arabia, the United Arab Emirates, and Japan aren't just buying chips. They are building AI factories. These are colossal state-funded data centers designed with a single purpose: to train proprietary, nation-scale large language models and achieve digital sovereignty. The goal is to control their own intelligent infrastructure, free from the influence of Silicon Valley or Beijing. The logic is brutal and simple. A nation's power in the 21st century will be measured not by its oil reserves or its military might, but by its computational capacity. NVIDIA's H100 and B200 GPUs became the foundational building blocks of this new world order, and the demand transformed them from mere components into strategic national assets. But there's a catch, a single terrifying point of failure that underpins this entire global ambition. Over 90% of the world's most advanced chips, the silicon hearts of these AI factories, are still born in one place: Taiwan. Fabricated by the Taiwan Semiconductor Manufacturing Company, TSMC, these chips represent the apex of human manufacturing. The geopolitical tension surrounding the island is therefore not just a regional dispute. It is a direct threat to the engine of global progress. As the US government implements new 25% tariffs on AI hardware this year to try and reshore some of this critical manufacturing, the pressure on the Taiwan Strait isn't just geopolitical, it's existential for every tech company in the S&P 500. The entire supply chain is a delicate, intricate dance. A single hiccup, be it a blockade, a natural disaster, or a political miscalculation, and the global economy doesn't just slow down. It goes dark. The flow of advanced silicon would cease, the AI factories would fall silent, and the digital transformation driving the world economy would grind to a catastrophic halt. This concentration of power, both in manufacturing and design, has created an unprecedented level of systemic risk. NVIDIA, through its partnership with TSMC, effectively holds the keys to the kingdom of artificial intelligence. Their ability to allocate this scarce resource gives them leverage over corporations and countries alike. They are not just a supplier. They are the gatekeeper. The sovereign AI wars are being fought with weapons that only one company truly controls, and those weapons are all manufactured in one of the most volatile regions on the planet. This fragile dependency has become the central unspoken anxiety of the modern world. The new Rubin chips don't just process data, they reason. Revealed in a surprise announcement that sent shockwaves through the industry, the Rubin R100 GPU represents a fundamental leap beyond mere computation. It is the first mainstream architecture designed for what experts are calling inference at the edge of sentience. While the Blackwell chips of 2025 were masterpieces of parallel processing, Rubin integrates dedicated neural engines that are engineered to perform complex, multi-step logical reasoning, a task that previously required massive clusters of older chips. They are an astonishing 10 times more efficient than their predecessors, a performance jump that defies the slowing pace of Moore's law. This isn't an incremental improvement. It's a paradigm shift. With Rubin, the cost and energy required to run sophisticated AI models plummets, making widespread, autonomous AI a commercial and logistical reality. This breakthrough creates what can only be described as a mode of complexity. NVIDIA's dominance is no longer just about their hardware or the CUDA software platform. It is about the seamless, vertical integration of the entire stack. The Rubin chips are co-designed with a new generation of networking technology, Quantum 3 InfiniBand, and a suite of proprietary software libraries that are years ahead of anything competitors can offer. Even if you could hypothetically design a better chip, you can't build a better ecosystem. The switching cost is no longer just financial, it's infrastructural. To abandon NVIDIA would mean abandoning the entire interconnected system of hardware, software, and networking that now powers the global AI economy. They have built a prison of convenience, and every major corporation and government is now a willing inmate. As we move further into 2026, the consolidation of power under a single corporate entity has become the most pressing question of our time. Regulators are scrambling to understand a monopoly that isn't defined by consumer prices, but by control over the means of innovation itself. The Great Rotation, a desperate multi-trillion-dollar push by governments and tech giants like Google, Amazon, and Microsoft to fund alternative chip designs and open-source hardware initiatives, is now in full swing. It is a rebellion against the Silicon Kingdom, but are they too late? Can the world survive a single point of failure, an empire whose foundations rest on a single company and a single island? Or are we all just living in an NVIDIA world now? Subscribe to Ocularly as we track the collapse or the crowning of the Silicon Kingdom.